Well, hello everyone. I'm really happy to be in the Litmus booth today representing NTT. I'm Gary Wood. I'm the global head of business development for our private 5G offering at NTT. It makes perfect sense that we are here in the Litmus booth, that I'm getting this chance to talk to you all, because private 5G, as one of the latest generation forms of wireless broadband connectivity that is really picking up momentum, is a natural adjacency, a very organic partnership with edge compute, with analytics of data at the edge, industrial IoT, and platforms just like the Litmus platform. So we're demonstrating some very cool things in the booth today, and we'll talk about those toward the end of the presentation. I do want to talk to some slides here that we'll talk about, as the title suggests, the role of private 5G networks in unlocking the power of industrial data. And as we all agree within this community across this entire campus of halls at Hannover Messe, that is one strong consensus that we have as a vendor community. It is all about the data. Clients alike would tell you it is all about the data and being able to unlock that data, harvest that data, analyze that data, and make sure that we're collecting all the available data. So these environments are now generating terabytes upon terabytes of valuable, meaningful data in your OT environments. We want to show you how we can reliably deliver all those data streams to the edge instance, to the Litmus edge, so that it can be properly analyzed, and so that Litmus clients and NTT clients alike can harvest value from that data. So that really answers the question and describes the role of private 5G. What we'll get into in my presentation here is a little bit more of the where is that being done, why is that being done, and dig a little bit deeper to uncover the benefit of private 5G as a superhighway for delivering these massive streams of data. As a premise here, in a problem statement to define what is this problem that we're actually solving, what is this challenge. I found, visiting the Litmus website, a really valuable artifact, their manufacturing playbook, that you can download for free from their website. And at the very front end of that document, it has a wonderful problem statement. I'll read it quickly here. Despite an early start in automation, manufacturing lags behind other industries in the race to digitally transform. Although many shop floor assets are connected, most companies are holding on to legacy systems and have failed to transform the way they share and use data intelligence across the entire business to drive productivity and efficiency. That's a very accurate statement of the problem, but it does have within it a separate problem, which is it necessarily so because Litmus wants to focus your attention in their document on the value that they are delivering with the Litmus Edge environment, but it almost skips over and glazes over, thank you, this statement buried in here. Although many shop floor assets are connected, that is the problem. Many of them are connected. The problem is they're not connected reliably enough, securely enough, and delivering the right kind of latency and throughput as they need to. And the reason for that is that clients primarily are utilizing the only broadband wireless network that they have available today in these OT factory and warehouse environments, and that is Wi-Fi. Wi-Fi is obviously pervasive. So clients are trying to get Wi-Fi networks to do things that they're really not designed to do. Wi-Fi was simply not designed to be an industrial grade, mission critical broadband wireless network. It is a fantastic technology. It's not going anywhere, but private 5G is simply a better answer than Wi-Fi for that mission criticality and reliability that these systems need. So let's talk a little bit about characterizing what those challenges are exactly. Reliability, low latency, I just mentioned. The fact that there are such large, massively large payloads involved here. So we need a network that can really deliver bandwidth, and bandwidth at the right time and reliably so. High availability, and here's a problem with regard to controlling that network environment. So often the availability of that network is under the control of third parties who are part of that solution architecture, rather than under the direct control of the enterprise client operating that network environment. And then finally, the security and privacy, the security of these networks. If companies are relying on, for instance, a cellular carrier to connect the things that need cellular connectivity and need 5G bandwidth, they're often sending that data outside their environment to the carrier's core, the cluster of software functions that comprise the core of that network, to be processed, authenticated, and then that data comes back into the factory environment or the OT environment. That's nobody's answer to security. So that's simply not going to meet the standard. So if we dig a little bit deeper, we could actually describe how these problems manifest and what these challenges are in very specific terms in the factory environment. But I want to really focus on one of these, which is in the upper left here, and that is mobility. So when we talk about clients utilizing Wi-Fi as the best available option they have today, short of deploying a private 5G network, and as an alternative to getting carrier metered cellular connectivity involved, which they have no control over at all, the mobility of a Wi-Fi network is one of the things that we see as presented to us by clients as a consistent challenge, a consistent pain point. The reason for that, and it's usually manifested in the form and around the use case of AGV connectivity. So clients are spending significant amounts of capital in AGVs to deliver raw materials to the assembly line, to move finished product around the warehouse, to remove waste byproducts, parts, components, whatever it might be. So AGVs are becoming pervasive in their use in these factory OT environments. And clients are understandably trying to connect those AGVs over the only viable option they have today, which is Wi-Fi. And that is simply not going well. Again, Wi-Fi struggles in the area of mobility. That's simply defined as the handoff, access point to access point of an AGV or any other device that moves at a high rate of speed or even a moderate rate of speed in that environment. Cellular was designed from the beginning to be optimized for that type of handoff, which is why we're all able to drive in our cars at high rate of speed and never have a gap in that conversation or data session on our smartphones. Wi-Fi, on the other hand, does struggle with that, and typically the problem statement we get consistently is those AGVs get disconnected, and that becomes very disruptive because then someone has to go down to the factory floor, reconnect those AGVs, and it's highly disruptive. So as an example, that's just one problem that we hear about very frequently. So then as we talk about what is the context and impact of these challenges, and is this private 5G network that's now evolving, it's still a relatively early stage technology. Cellular is not new, but the private implementation of a true 5G cellular network under the complete control of an enterprise without the involvement of a carrier in any way, that model is still relatively early stage. So what is the technology delivering today, and what does the path forward look like in terms of the metrics that actually tell me what kind of performance and reliability do I get out of this network? So as you look at these metrics across the top, obviously you see at the bottom the real need here is in the area of supporting my IoT applications, driving data toward my IoT analytics platforms, edge instances like the Litmus edge, and also to meet the demands, the voracious data demands of AI. So what are the metrics that actually show me that we're on a path to get there, to meet that challenge? So as you can see, we're on a trajectory to meet, and I'm told by industry analysts that the timeline for this looks like roughly in the 3 to 5 year time horizon, we will achieve 10 gig up, 20 gig down, which is considerable. It's actually frankly amazing for wireless. We're currently sitting at just above a gig throughput, but we're on in that time horizon, we'll achieve these metrics, and that will be a great day for the industry and for Industry 4.0. And latency, equally importantly, latency, sub-millisecond rather, latency, to meet the demands of the applications like AR, VR, machine learning, deep learning, digital twinning that really need that ultra low latency. And equally so, connection density. So as more and more sensors become SIM-enabled, cellular-enabled, we'll have greater density of these on the factory floor and in the distribution center environment, in heavy industrial environments. And so we'll need the ability to densify and support eventually millions of devices. And we're on a path to get to 1 million per square kilometer, which would be a great milestone to hit. And then finally, the only one I'll hit here on the slide, the last one, is the efficiency of 5G compared to its predecessor, 4G technology, 3 times better radio efficiency, which will save on capital cost. And so that's a very important point. So as we look at then, what are the trade-offs, what are the problems, how do I manage this, and what can I expect from this network? So first of all, depending on the geography and where you are and what connection speeds you'll get, guaranteed performance will be important. SLAs will be important. If private 5G is to take its place alongside more established broadband network technologies, it will need to deliver SLAs. In the case of NTT, we actually deliver a financially backed SLA for network uptime, network availability. And that will continue to broaden and evolve to meet the demands and the requirements of enterprise network organizations and to make private 5G a bona fide broadband network technology. Secondly, all the traffic stays on site with a private 5G network. And again, that's vitally important for maintaining the security of your data in the private 5G architecture when implemented the way NTT delivers it with the core and the RAN and all the assets there at the edge in the OT environment. None of that data is leaving your environment. It all stays behind your firewall and it meets the most stringent security requirements. Taking advantage of the greater power level, transmission power level allowances that we have with private 5G as compared to Wi-Fi, we're able to achieve much lower density with a private 5G network to cover the same geographic area. So on average, to characterize that, in an indoor environment, we're typically seeing 4 to 5 Wi-Fi radios per 1 private 5G radio to cover the same space. When we get outside and transmission power levels are higher, we actually widen that gap considerably. We've seen anywhere from 10 to 1, 21, even up to 50 to 1, depending on the environmental conditions outside. So that gap really does begin to widen, and the advantage of private 5G outdoors really does become very significant. And then finally, the ability to control the network and apply policy. When the carriers introduced 5G technology and rolled out their 5G networks, they made a fairly big deal about network slicing. They rolled it out as principally a consumer offer, but the one bone that they did throw to their enterprise clients was this concept of the network slice. We in the private 5G community, and specifically with our partner Shalona, who has patented their technology that they call microslicing, very appropriately, they take that same slicing concept, the macro network providers, the mobile network providers like all your major wireless public licensed cellular providers, they take that from a macro level and take it down to a very granular level, allowing you to apply policy per device, per employee, per location, per application being accessed, and manipulate those variables to create a very complex taxonomy of policies that will drive the behavior of your network and the connected experience. Incredibly powerful control that's never been available to the enterprise before as it relates to cellular connectivity. Very quickly, this just shows the evolution that we are still in the middle of from the traditional model of cellular being exclusively the domain of carriers, public license carriers, and how that is evolving to the pure private 5G network as we would define it, as the industry in private 5G would define it. And it starts with RAN being pushed down to the edge. In the beginning, carriers might put a small cell in your factory, use their macro network and their centralized core, and call that their private 5G offer. I don't think that meets anybody's definition of private 5G. The next iteration of that was to actually deploy RAN assets in your factory or in your local environment, but still hold that traffic to a centralized core. Then it advanced to some kind of shared core, hybrid core with at least some of those functions operating at the edge on customer premise. And then finally, the push with partnerships between the carriers and the hyperscalers, the cloud, public cloud guys, to actually deliver functionality at the network edge, not necessarily on-premise, but cores and applications functioning at the network edge. We take it to all the way to the very maximum, the very extreme, where all compute and all RAN assets and the core functionality is entirely on the customer premise, at the edge, behind your firewall, delivering the lowest latency and the most optimal security possible. The one theme here that I want to focus on is this concept of control and all the tools and all the resources available to the enterprise through this evolution. So now spectrum is available to the enterprise directly without a carrier for the first time. That tectonic plate shift is what is driving the growth of our industry. The other thing that is changing that is often overlooked is the fact that control over the core, again, that cluster of software functions that represent the brain of a cellular network, that is now coming downscale to the enterprise, is now running completely at on-premise, at the edge, in your environment, again, delivering that low latency and optimal security, but also giving the enterprise, for the very first time, direct access to those functions, those network policies. So the way devices are authenticated, the life cycle of the SIM and SIM subscription, all those tools are available to the enterprise for the first time. That is a watershed change, and a big one, an impactful one. This simply shows you what an typical architecture of a private 5G network looks like. Every vendor's architecture looks basically similar. What I want to stress here again is all these functions operating at the edge, and I want to highlight that now through our partnership with Litmus and through partnerships with a mutual partner that we have in companies like Tulip and the Tulip Manufacturing Execution System, or MES, we can now run the Litmus analytics stack on a device at the edge. We're demonstrating that on a very small device in the booth today and at this show, a NUC class device with the instance of the Litmus Edge running. It can also create an application environment in that on that edge instance, very powerful, and take its place alongside these other functions running at the edge in the customer premise. We have some network management, portal, and SaaS functions running in the cloud, but everything else about the control of that network sits at the edge. And again, architecturally, a wonderful advantage. Very quickly, where this sits in the NTT portfolio is it's in a portfolio very organically, very symbiotically with adjacent technologies like IoT, like edge compute, and another one I'll touch on very quickly in a second, which is global connectivity and ubiquitous connectivity using public cellular in combination with private 5G. And this is how we group it, and from an NTT standpoint, in the same cutting-edge technology portfolio. So our value proposition then looks like this. In the upper left-hand box, those competencies, those capabilities, that portfolio, private 5G, edge compute, IoT. We then combine that with our ability to broker on behalf of the client agreements that will give the client access to spectrum where they need it, anywhere around the globe, where their operations are. That's become a very important facet of the complete value that we offer to clients. We also, again, have Transitel, a wholly owned company that is a global mobile virtual network operator, or MVNO, that provides public licensed ubiquitous cellular coverage on a macrocellular basis to keep objects, devices, assets fully connected as they leave the private 5G environment, travel potentially over by land, on truck, on train, in macrocellular coverage, public license coverage, and then back to another private 5G environment again. Very powerful. We combine that with our deep competencies for global network operations centers, follow the sun support, 24/7 support. Our managed services, we're a Gartner leader in network managed services. That's a very deep competency, so we do deliver this entire offering on an as-a-service basis, as a fully managed service, completely OpEx-based. And finally, through the legacy NTTData capabilities of very robust application development and application integration capability that we can deliver that, again, has real power and value when you consider it in the context of the Litmus Edge and the Litmus application environment that's being enabled here in partnership with NTT and Litmus. The spectrum picture that we talked about, so when we talk about the where of private 5G, this shows you the evolution of where there is regulatory set aside of spectrum that represented by the green zones, where that process is ongoing and on a path to becoming a regulatory set aside for spectrum freely available to non-carrier private enterprise entities represented in the purple shades. You see India and Italy highlighted there. And then you also see the yellow zones, and those are the zones where it's evolving toward a regulatory framework for access to that spectrum, but where NTT has partnerships because we're part of that global carrier community, both through Transitel, our global MVNO, as well as through NTT Docomo, one of the largest carriers in the world. We can broker those arrangements and agreements, and that's a big part of the value proposition we bring to our clients. Again, showing that public-private roaming model. We don't see a huge demand for this yet, but I think as this model takes hold and clients become aware of the capability for ubiquitous connectivity across long distances between their locations, between a factory and a distribution center, for instance, we'll see this big value proposition begin to really get traction. And finally, just some granularity on what our managed service looks like. So we do deliver private 5G as a completely managed service, end-to-end, design, build, run, support aspects of the delivery of a private 5G network. And it contains all these elements. And we're able to, again, leverage our deep competencies in managed network service delivery and managed service hosting in the delivery of private 5G. Lastly, the use case discussion is in the context of manufacturing, IIoT, Industry 4.0, smart factory. The use case framework is considerable. The major categories as we see them, and as the industry typically classifies them: group communications, push-to-talk technologies, a better next-gen way to deliver that capability over a private 5G network, and utilizing open smartphone OS environments instead of purpose-built devices. Connected workforce, many of those devices involving AR, VR, wearables, goggles, and the like, HoloLens and similar devices. Autonomously guided vehicles, AGVs, as well as autonomous mobile robots. Anything that moves in that OT environment that is mission critical, we want to connect to a private 5G network. Machine vision or computer vision as well. So you can see that the use case discussion is a deep one. There are many categories to explore, and most of our clients are just beginning to scratch the surface there. So as I mentioned in closing, we do have the demonstration in the Litmus booth. We have private 5G actually connecting, the model here being the connected devices, traveling with data being streamed over private 5G to the Litmus Edge instance, in this case being demonstrated on a NUC class device, which is very powerful because it gives you the flexibility to take that device and deploy it out into and integrate it into the OT infrastructure. And then private 5G in this case, very unique, also being used for the backhaul from that device and from the Litmus Edge to back-end applications that need that data once it's been aggregated, normalized, analyzed, scrubbed. So it's then clean and could be then aggregated for consumption by those applications, mission-critical applications that need it. I'm going to close on that. We look forward to seeing you in the Litmus booth. I hope you can visit. If not, please track these topics on our website and the Litmus website. There'll be some very powerful things happening through this partnership, and we're very excited about our partnership with Litmus. Thanks for the opportunity to all the Litmus folks that helped. Thank you, and we look forward to working with you and meeting our mutual clients. Thanks.